So in 10.7, we're going to do we're going to factor special products, but we're going to do two certain types. One, we're going to do the difference of two squares. It's got to be difference, which means subtract, and it has to only be two terms. And they have to both be perfect squares. But they might not be perfect squares, but there might be a greatest common factor. If you have one, divide it out. Now after you do that, if both terms are perfect squares, meaning you can take the square root nicely, and you have subtraction, you can't do this with addition, so don't even try. Now we can set up two parentheses. So 16 and 49, there's nothing that goes into those, and they are both perfect squares. So now I'm going to square root. Square root of 16 is 4, and x squared becomes x. So 4x, 4x. Square root of 49 is 7 and 7. I want them to multiply to be a negative, so one has to be a plus, one has to be a minus. Doesn't matter which one you put first, because it's the same thing, just one's a plus and one's a minus. And that's it. Now 15 and 18 are not perfect squares, but let's do that one. I can divide both of them by 2. So if I take a 2 out, I get 25m squared minus 9. Those are perfect squares. So let's break that up, but make sure you keep the 2 on the outside. Square root both of my numbers, I get 5m. Square root of 9 is 3. Make 1 a plus and 1 a minus, and you're done. All right, and the last one. See, this is much better than the last section. 3 and 12, 3 goes into both of those. They don't have a letter in common, but it's okay. If I divide out the 3, that's what I'm left with. These are both perfect squares. Y squared is y and y. 4x squared, the square root of 4 is 2, and x squared would be 2x. 1 plus, 1 minus. So it's okay if you have letters in there, just keep them where they belong. Y's go in the front of the parentheses, and x's would go in the back of the parentheses. Okay, so pause and fill all that in before moving on to the next type of special products. Now, the next type is perfect square trinomials, which are harder to identify, but always check for GCF. That's first step in everything. But if the first and the last terms are perfect squares, so like 4 is a perfect square, 9 is a perfect square, 25 and 49, then usually this is a perfect square trinomial. So we're going to see what we can do here. 4x squared is 2x and 2x. 9 is 3 and 3. Now they have to multiply to be a positive, but add up to be a negative, so they both have to be negative. Let's check it. This is negative 6, this is negative 6, which does give me negative 12, so this does work. Okay, the next one. 5n, square root of 49 is 7 and 7. Everybody's positive here. Let's check it. 35 and 35, and that does give me 70. Okay, so it just helps you identify which trial and error method to use if you've got perfect squares on the beginning and the end. And that's it.